lesson will be recorded, so later you can refer back to the video as your further references. Assalamualaikum and a very good morning to all of you, students of 4A, 4 Baiduri and 4 Citrim. So wherever you are, I hope you are in a very good situation, in a good conditions. Even though some of you are feel bad here, I can see from the poll, never mind. So today we continue with our lesson on physics, but before that, I would like to make a correction here on the answer I shared to you on our previous exercises on refraction of wave. Okay, if you refer to this diagram, okay, for diagram D, there is a small mistake there in drawing the wavefront for the deep water region. Okay, you can see, I think the rest no problem. In diagram A, we can see the water propagate from deep, entering a shallow region and then went to deep. So here the wavelength decreases and here the wavelength increases back. This one also the same. So from deep to shallow, it propagates towards, okay, the normal, where the wavelength becomes shorter at the shallow region, and then went back to deep region. So from shallow to deep, it refracts away from normal. You can see that the refracted wave is away from normal and the wavelength become longer. Okay, for C also no problem. In shallow region, shorter wavelength. In deep region, longer wavelength. Again, shorter to deep, shallow to deep is away from normal. Okay, the problem is with number 4, diagram D. Okay, the first part, no problem, from deep to shallow. Okay, it propagates towards the normal with a shorter wavefront here. But then, the problem lies here, went back to deep region, it should become longer. So you draw the wavelength should be longer. Ini dia lukis sama kan? So it's supposed to be longer. So you please make correction on this drawing. Okay, the number, how many lines you should draw? At least 3. Okay, at least 3 wavefront. You don't have to draw exactly the same. It is enough for you to draw 3 lines. 1, 2, 3. Okay, this one also the same. You draw 3 lines. So this one you can erase to make the wavelength greater. Okay, so draw 3, show 3 wavelength enough already. Okay, same goes to the other drawing. Okay, so I hope you are clear with this correction. Anything else you would like to ask on the previous exercises? Ada apa lagi nak tanya? So I hope you are clear with this correction and you can make correction as well in your workbook. This is on page, which page is this? Can someone respond to me? What page is this, the correction? Can you check from your workbook? Okay, so later you can check, okay, the correction on drawing. Okay, so students, now let us proceed with our lesson. So today I continue with refraction of wave. So last time we have discussed the first 3 learning standard, and today we are going to continue with the 4th learning standard, which is to solve problem involving refraction of wave. Okay, so are you good to go? Are you ready to solve a problem here? Boys and girls? Okay, Sinwei said, thank you for your response. Okay, so let's take a look. What is the question that we have for today? Okay, before that, let us have a review on how is the propagation of water wave from the first diagram, from deep region to shallow region. And then in the second diagram here, you can see also how's the changes in the propagation when the wave travel from a different depth. Okay, in the different region here, you can see the wavelength is longer. Okay, and in the shallow region, the wavelength become shorter and it propagate towards normal. Okay, here you can see from the side view how is the changes of the wavelength. Okay, in the deep region, the wavelength is longer, while in a shallow region, you can see that the wavelength is shorter. Okay, the changes in the wavelength is due to the changes in speed when wave propagate from different depth. Okay. Okay, students. So from the previous diagram, this is the formula of speed which we learned earlier, where V equal F lambda. Okay, V is wave speed. F is what is F represent? Anyone?
Frequency.
Yes, very good. F is the frequency and lambda is the wavelength. Yes, so wave speed is frequency multiply lambda. Okay, so in the deep region, okay, the speed is F lambda 1. Okay, so this one V1 is F lambda 1. Lambda 1 means the wavelength in the deep region. Okay, while in the shallow region, speed V2 is equal to F lambda 2. Okay, this is the wavelength in the shallow region. Okay, if you see here, F is constant. Okay, frequency is the same. Why F is the same? Why frequency is the same? Why frequency is constant?
Same generator.
Yeah, same generator, same sources producing the wave. Very good. Okay, so when we do the operation, so it will become V1 over V2 equal F1 divide lambda 1 divide lambda 2. Okay, so this is the relationship on the speed and wavelength of a water wave in deep and shallow region. Okay, V1 divide lambda 1 equal V2 divide lambda 2. Okay, this one you bring all the 1 to the other side. So this is the speed in deep region and the wavelength in the deep region equal to the speed in the shallow region divide with the wavelength of the shallow region. So kalau you tengok semula V1 divide lambda 1 ini represent F. Okay, this one also V2 divide lambda 2, it represent F. So frequency of the deep region equal to the frequency of the shallow region. Okay. So let us check on this question on how to apply that formula. So you are given this diagram. A water is propagated from a deep region entering a shallow region as shown in this diagram. Okay, given the wavelength here is 3 cm and here in the shallow region the wavelength is 1.5 cm. So the question is, if the speed of the water wave is 5 centimeter per second in the deep water region, so you have to find the speed of the water wave in the shallow water region. Okay, fine, students. What is the speed of the water wave in the shallow region? Okay, you are given 3 information here. Wavelength in the deep region, wavelength in the shallow region, and then speed in the deep region. So we can find the speed in the shallow region applying the formula I showed to you earlier. Okay, use this formula. Find. So what are we looking for? V1, lambda 1, V2, or lambda 2? Which one we are looking for? We are looking for V2. Okay, speed of water wave in the shallow region. So what is it? Okay, simple mathematics only. You just do the substitution and find the speed of water wave in the shallow water region. So what is it? Anyone? What is the speed? Is it 1.5, 2.5, 3.0, or 5.0? Which one?
2.5.
2.5. How about the rest? What do you say? So we just do the substitution and make sure you put them in the correct houses. So for V1, speed of wave in the deep water region is 5. And this is the wavelength, 3 centimeter. So we are looking for V2 where the wavelength is 1.5. So by this, V2 is yes, 2.5 centimeter per second. Okay. So answer is, this one's supposed to be boy, A, B, C, D. So 2.5 centimeter per second. Okay, now let's check on next questions. Okay, you're given diagram 3. It shows a ripple tank with a sloping base, okay, and a vibrator being vibrated. So you can see that this is the sloping base. Okay, dia punya tapak tu tak sama, dia sloping, got an angle there. And you are asked to determine the correct pattern, can be seen on the screen down here. So when the vibrator is switched on, how is the pattern of the wave appear on the screen? Will it A, B, C, or D? Students, what do you say? It is similar to question number 5. You can see a tilted basin contain water. Water is streamed at a constant rate. Constant rate mean at a fixed frequency, okay, into the basin as shown in the diagram. So you have to choose the correct pattern of the wavefront that we are going to observe in the basin. So what is the answer for 4 and 5?
A.
Yeah, come again.
A. Is it A?
A. Number 4A. How about number 5?
Also,
The answer is A too.
Also A, the same. Okay, let us check for the answer. So you can see, yes. Okay, so in the shallow, this is the shallow water region where the wavelength is shorter. Okay, and then in the deep region, the wavelength is longer. So same goes to number 5. Here is the deep region, so the wavelength is longer. And the shallow region, the wavelength is shorter. Okay, very good. You can see refraction of wave occur back due to different in depth of water region. Okay. And now let's check on the next question. Now we have this diagram. Okay. It shows propagation of water wave from region P, okay, to region Q. So this is the direction of propagation from P propagates to Q at different depths. Speed of wave is 18 centimeter per second given in region P. So you have to determine the speed of wave in region Q. Okay, so you are given this information. Okay, from this end to the other end is 12 centimeter, and here goes the same. Okay, so how to find the speed of wave in region Q? So I give you 30 seconds or 1 minute, okay, to settle for this. Find the speed of wave in region Q. And this is a question on analytics. So you have to do a few analyses before come up with the solution. If you are done, you can share your answer in the in-call messages so we can discuss. All right. So what information you can get from here, 12 centimeter and 12 centimeter? It tells us it tells what? From this line given, what can you find from there? Yes, it can give you lambda, okay, lambda or the wavelength in region P and region Q. So what is the wavelength in region P? What is the wavelength in region Q? You can see how many lambda there.
4 lambda.
Yeah, here for P we have 4 lambda. So this is the first lambda, 1, and then 2, this is 3, and 4. So which means 12 divided by 4 mean lambda is 3 cm, right?
Yes.
How about Q? How many lambda we have there?
8.
So we have 8. 1, 2, 3, 4, 5, 6, 7, 8, which means lambda is 12 divide 8. So we'll give you
3/2.
3/2 in decimal places is
1.5.
1.5. Okay, ini 3 cm, ini the lambda is 1.5 cm. So now you can find for speed. Okay, ini given speed is 18 centimeter per second, Vp. Okay, this is lambda P, this is lambda Q. So now we can find VQ. So this is how we analyze the information given. So now you have lambda P, lambda Q, you have VP, so you can find VQ. Okay, what is the value for VQ? Speed in region Q. Yes, Jing Swan 1.5 lambda Q. Okay, so again, so this is the method how we find the wavelength. So first we find the wavelength. So wavelength in region P, lambda 1, or you can use lambda P, no problem, it is 3 centimeter. Okay, and then in region Q, we can label as lambda 2, or you can use lambda Q, no problem. So it is 1.5 cm. Okay, then we can do this. We can apply this equation. V1 divide lambda 1 equal V2 divide lambda 2, or you can use VP divide lambda P equal VQ divide lambda Q. So it is 9 centimeter per second. Okay. So did you get 9 centimeter per second?
Yes.
Okay,
Yes.
very good. Okay, simple question only, right? The keyword is you must know how to find wavelength in region P and in region Q. Then only we do the solution using this equation. All right. So when you do solution, the switch step you have to show in order to gain mark. Okay, you better show this how you get 3 cm. This one also, ini tak perlu list out pun, no problem. Then you show what equation you are using and you show the substitution and final answer with correct unit. Okay, so this is what we call as a proper working. And then let's check on the next questions. Okay, now we are given this diagram. It shows a plane water wave with a frequency of 10 Hz, propagating from deep region to the boundary of shallow region PQ. So this is the boundary of shallow region. Okay. Then the speed of water wave in the deep region is given 30 centimeter per second. Okay, so student, you have to find wavelength lambda as shown here. Okay, so they give you the frequency, they give you the wave speed, so you have to find lambda. Okay, and then B, calculate the speed of the water wave in the shallow region if the wavelength in that region is 1.5 cm. So how to find lambda in A? What equation we apply here? Okay, how to find lambda? You have the frequency, you have the speed to find lambda. So how we relate frequency, speed, and lambda? Okay, anyone?
V equals to lambda times frequency.
Yes, very good. So V equal to F lambda. Okay, so the wave speed is given 30. So frequency is 10. So by this, the wavelength is 3 cm. So 3 cm is the wavelength in the deep region. Okay, so from A, now we can find B. Find the speed of water in the shallow region. So again, we apply this, you can apply this equation also, or you can use V1 divide lambda 1 equal V2 divide lambda 2. Mana-mana pun boleh guna. Okay, the frequency is the same. So we can find the speed is 15 centimeter per second. This one if you use the first option. Okay, second option, you can also apply this equation. V1 lambda 1 equal V2 lambda 2. So if you're using this is 3 and this is, this is 30, here is 3, and then we are looking for V2, here is 1.5. So you're going to end up with the same answer. Here is 15 centimeter per second. So any method is acceptable. Okay, are you clear with this question? All right, so let us move to the next one. Okay, now get back to this diagram. Now using arrow, draw the direction of propagation of the wave in the shallow region, and then you have to sketch the wavefront of the water wave refracted in this region. When you are dealing with refraction of waves, sometimes you cannot run away from drawing, okay, or sketch the propagation of wave involved. So how to draw? So our wave is propagating from deep towards shallow region, from deep to shallow region. So students, away or towards normal, from deep to shallow. Water wave propagate from deep to shallow region. Will it be refract towards or away from normal? Which one? Who say towards normal? Who say away from normal? Okay, anyone? What do you say? Any idea? Away or towards?
Toward.
Towards or away? Okay, which one? The rest of you, what do you say? Towards or away, students? So let's take the second poll. Okay, from deep to shallow, propagate towards or away from normal. Okay, choose your answer. Pull your answer. Okay, pilih jawapan. From deep to shallow, propagate towards or away. We have one word for towards. Anybody say away? Come on, the rest of you. Pick the poll there. You say towards or away. Propagating from deep to shallow. Yang mana? Look at the second poll. Okay, check on the poll there. So the answer is 2 votes for towards now. No one else vote for away. What do you say, the rest of you? You nak pilih yang mana? Undi yang mana? Towards or away? Sinway say towards. Okay, 4 votes for towards normal now. Still no votes for away. So what do you vote for? Okay. So we check. So from deep to shallow region, what happened? It will propagate towards normal. Okay, towards normal. And what happened? The wavelength decreases, become shorter. Ini tengok formula yang cikgu bagi. Duit saya tiada. Okay, so deep to shallow, propagate towards. D itu is for deep, shallow towards normal. Okay, when water wave propagate from deep to shallow region, it will refract towards the normal line. Okay. If from shallow to deep, remember my keyword, saya dapat ampau. Okay. Shallow to deep, propagate away. Ampau is for away. Okay. You dapat ampau, you pergi sana sini, kaki panjang, nak beli barang. Tak ada duit, diam-diam di rumah, towards normal. Alright. Okay. So this is how we draw the direction of propagation. It is towards normal, and how we draw the wavelength or the wavefront, it becomes shorter compared to the deep region. And remember, you must draw at least 3 lines. If you draw 1 line only, it will consider as wrong, rejected. Or you draw 2 lines only, consider as wrong, rejected. You draw 10 lines, not necessary, don't waste your time. So enough to draw 3 wavefront, 3 lines to show the wavelength changes. Alright, okay, now compare the frequency, the wavelength, and the speed in the deep and shallow region. So how we compare the frequency? So what can you say about the frequency? Does it change?
Equal.
Equal. So frequency is the same, okay, in both region. How about the wavelength? In the deep region, we can say it is greater than the shallow region. While for the wave speed, in a deep region, the wave speed is higher or greater compared to the speed in the shallow region. Okay. Okay, so class, that is a few example of problem solving on refraction of waves. Okay, I give you a short break, 1 minute break, before we go to check on a few example of SPM past year questions on refraction of wave. Okay. So you nak pergi minum ke, you nak basuh muka ke, boleh lah. I give you 1 minute short break. Okay. So we will continue at 11:03 AM. Okay, sambil itu ada soalan you nak tanya, you boleh tanya. You may ask if there is anything you would like to clarify with. Okay. So do you feel excited you can come back to school soon? So I believe everyone is feel happy. Semua tak sabar nak balik ke sana. No, why Ong Cheng? You don't miss your table in school? You don't miss your place, your seat? Anyone forget already where is 4 Akid, where is 4 Baiduri, where is 4 Citrin? Sudah lupa kelas di mana? Not yet, haven't complete homework. What homework do you have? What subject got a lot of homework? You do your homework every day, so it won't burden you. Teacher, how to write surat untuk ambil cuti? Why you want to travel somewhere? Kampai? Cuti for what? Cuti sakit? Nak pergi mana? Pergi melancong ke? That one you have to refer to your form teacher. Okay, normally we write surat rasmi lah. Okay, but it depends what is the cuti for. Okay, is it emergency leave, medical leave, or a vacation leave? Vacation mungkin susah sikit lah. Okay, but you can try to ask your form teacher. Alright. Okay, students, so I think we can go back to our discussion. So now let's check on SPM practices on refraction of wave. Okay, we go for paper 1 first. Yeah, I have a few questions here. Diagram shows water wave propagating in an area of different depth. So the keyword here, wave, water wave propagating in different depths. So you may highlight, okay? And this is the direction of propagation. Okay, from deep entering a shallow region of this shape. Okay, so which of the following diagrams show the propagation of wave correctly? So which one is your choice? A, B, C, or D? What happened? How's the pattern of the wave in this shallow area with the convex perspex plate here? So Nicholas say B. What about the rest? So do you say Ong Cheng say D?
Donkey.
Nicholas say OC. Anna, A. Yeah, Sinway, you say? Donkey. Okay, how about Angus? What do you say? Angus, Wong Yi En, Carrie, we have 88% here, but the same person respond to the question again and again and again. Chong Yi, what do you say? Pauline, Eric, both Eric, Yu Jing, Pei Ying, Rowan, Jason, Kerwin, what do you say? Yang cikgu tak sebut nama, jangan merajuk pula. Okay, later on I'll call you. Who else? Okay, down there we have Yujia, Kisya, and Yujian. Okay, Yujia, it's a very good video you made on the keselamatan jalan raya. Okay, congratulations. Ong Jin Pei, so Wanjia say D. So the answer is D. Okay. In a shallow region, first of all, you have to look at the wavelength. It becomes shorter. Okay, shorter. The wavelength decreases. So you can reject B and you can reject C. So we have two left. Okay. So which one? If you look from the diagram, which one is a logical diagram? So convex lens. Convex lens is to converge. Okay, converge the wave. So after passing through, the wave will be focused on one point. So answer is donkey. Okay. So yang jawab salah itu number 17. Answer is donkey. Congratulations for those who get it right. Okay, now we have concave shape. Concave shape of perspex blocks. So which one is the correct pattern when the wave pass through the block? Okay, remember convex lens. Just now we have convex shape which is converge the wave into a point after passing through. And then how about concave shape, student? So concave shape will diverge. Okay, dia akan diverge. So which one show diversion? Divergent. So you can, mana you can reject? Ini you can reject. Okay, because it should be diverged in this direction. Okay, this is the direction of propagation. So you can reject C and D. So you can consider A and B. Again, above the perspective block, what happened to the wavelength? It should be decreases, shorter. So answer supposed to be B. Yes, congratulations for those who answering B. Okay, you got it now, students? A water wave passing through convex and concave shape of perspex block. For concave, it is diverge. For convex, it is converge. Alright?
Teacher,
Yeah.
the question didn't mention that is dark region to shallow region. So if
Mana?
region is not mentioned,
Normally, when we place a perspex block, so it will create a shallow region on the ripple tank. Okay? So you have to understand it on that way. Dia assume kamu faham when you put a perspex block there, it reduce the depth of the water above. Alright?
okay.
Okay. It's a good question anyway. Okay, now let's check on this. You are given a cross section of water wave in a ripple tank. Bright and dark regions are formed on the screen. So the screen is down here. Above here we have a lamp. So when you on the lamp and we on the vibrator, this is how the wave form. And this is the pattern you see down. Okay, bright, dark, bright, dark, bright, dark. Okay. So the question is, the first one, what type of wave is water wave? So water wave is what type of wave?
transverse,
So how many type of wave we have? We have transverse and longitudinal, right? So this one is, yes, transverse. So water wave is a transverse. So you can see there is a crest and there is a trough. So it is a transverse wave where the particle vibrate perpendicularly to the direction of propagation of the wave. So it is transverse wave. One mark for that. And then B, in this diagram, you have to complete the light rays pass through one of the crests to show how a bright region is produced on the screen. So you can see there are 3 crests here. You can choose any of these crests to complete the ray diagram. So just now I mentioned, if you look at the crest, the shape is appear to be convex or concave shape, student, the crest. The crest of the wave, the shape is convex or concave shape.
convex,
It has a convex shape, right? You can see it has a convex shape, while the trough has a shape of concave. So for convex, when light passing through convex, so what happened? It will converge to a point. So you draw a line, converge to a point. Okay, so all the light fall here. That's why it produce bright region, since all the light focus on this point. While what happened at the trough, if they ask you to draw, okay, another line on the trough, so how should we draw? We draw like this. After passing through, so it diverge. Okay, this one also. Don't forget to draw the arrow as well. So it diverge. So that's why it leaves a dark region here. Okay, since the light is diverged away. Okay, so you can draw at any crest from either here or this one or the next one. Okay, so they give you 1 mark for that when you show this. And again, don't forget to draw the arrow as well. Okay, then in number 2, you have to mark one distance which is equal to a wavelength and label them with a symbol of lambda. So which distance represent the wavelength? So where to mark? I erase this first. So where to mark? Where to mark the wavelength at? So you can mark the wavelength here, either from the first crest to the second. So this is considered as lambda, or it can be from the 2 consecutive bright fringes. Okay, bright region, this one. Or it can be also from the 2 consecutive dark region. Okay, anyone, mana-mana pun boleh. Okay, label it as lambda. Okay, now when the frequency of the wave is increased, what happened to the wavelength and what happened to the speed of water wave? Okay, any idea? When the frequency of the water wave is increased, what happened to the wavelength and what happened to the speed of water wave? Okay, anyone would like to answer C1 and C2? What happened to the wavelength when the frequency increases? So from our formula, remember V equal F lambda. Okay, V, so when F ini increases. Okay, so what happened to the wavelength? Wavelength is decreases. Yes, wavelength decreases. Okay, wavelength decreases. And then what happened to the speed? Any changes?
Ada increase ah?
Mana? Speed. Speed of wave.
Increase.
Sinway say increase. What about the rest? What do you say? If you look from this formula, when F increases and then lambda decreases, what happened to V? Kalau salah malu loh, tak apa, we are learning. Okay, yang malu kalau you tak cuba langsung. Okay, you tak tahu you faham ke tidak. Okay, what happened? But then lambda decrease too. Okay, how? From here, okay, look at this relation. When frequency increases, lambda decreases. So what happened to the speed? Supposed to be constant. Okay, remember when you have 3 variables, when one is manipulated, the other one is responding, the third variable should be constant. Okay, they can be either one. Okay, students. So frequency increases, lambda decreases. So speed in this case is constant. So the speed is constant. Okay. What happen now if you maintain the frequency? Kalau you kekalkan frequency, so one is increasing, another one is decreasing. So that is how the relationship goes. Okay. Okay, now we go to this next question. Number 1. Okay, this is diagram A. It shows a side view. Tengok daripada tepi. A side view of 2 ripple tanks. So we have ripple tank here, another one is here, and we have region X. Here we have region Y. Okay, this is the first ripple tank, region X. The second ripple tank is region Y. Alright. So when the motor is switched on, the water wave with the same frequency are produced. So you can highlight this. So both ripple tank has a equal or same frequency. Okay, now diagram B shows the waveform on the screen. So this is X from the ripple tank 1 and this is Y from the second ripple tank. So what is the meaning of frequency? First question. This is recall, question on recall. Do you recall the meaning of frequency? What does frequency represent?
Reciprocal of period.
Ya, boleh tak jawab reciprocal of period?
Number of complete oscillation 1 second.
Yes, very good. That is the answer. Okay, what is frequency? Number of complete oscillation or number of complete wave in 1 second. Okay, Ong Jang, you answer this way. Number of complete oscillation in 1 second. Okay. Okay, then observe diagram A and diagram B. Compare the depth of water in region X and region Y. So this is region X, this is region Y from side view. And from top view, this is region X, this is region Z. So what can you say about the depth of the water in region X and Y? So depth you can see from the first diagram, X and Y. Which one is deeper? Which one is shallower?
X is deeper.
Okay, so you can say depth of water in region X greater. Okay, compare. So you can use the mathematical symbol of greater, X greater than region Y. Okay, enough to write region X greater than region Y in structure. Okay, in structure enough if you write region X greater than region Y. But if you answer in essay part, which is part B of section B or section C, it must come together with a parameter. Depth of water in region X greater than region Y. So this is the difference how we answer comparison question on structure and in the essay part. Okay, now second, compare the wavelength. So wavelength we can see from the second diagram. Compare the wavelength in region X and region Y. So how do you compare the wavelength? Again, which one longer, which one shorter? So you can see clearly in region X is longer or shorter compared to Y. Region X is, yes, longer or greater. So wavelength in region X is greater than region Y. Okay, again, you can use mathematical symbol, no problem. But you don't use the arrow. Jangan guna simbol macam ini. Region X high, region Y low. This is not a functional mathematical symbol and it is rejected. Okay, make sure you use a correct mathematical symbol to represent equal, greater than, or smaller than. Right? Okay, then C, number 3, relate the depth of the water to the wavelength. So what is the relationship between depth and wavelength from the previous diagram or from the previous observation you write? Okay, how to say?
Directly proportional.
Directly proportional. Any other answer? Okay, what is your opinion? So you can say depth of water increases, wavelength increases. Okay, depth greater, wavelength greater. Or you can say depth of water directly proportional to wavelength. Okay, acceptable. As long as you show both increasing. Okay, then question C. Okay, this one is a bit long explanation, 3 marks. So you asked to explain why the wavefront in seawater follow the shape of the shore when it is approaching the shore. Okay, what causes the changes in the shape of the water propagating from the ocean towards the shore? Okay, any idea? 3 marks. So how to score 3 marks here? Okay, try write your answer. I see how many marks you can get there. So now we call for who else I didn't call? Ke Yi, Hong Jing, Jin Pei. You are entering with 2 devices. Jun Wei, Jun Yu, Setian, Yu Hui, Hu Ying, Inze, Yiting, Shamel, Anting, Ding Suen, Yun, Wei Xiang. Tuan Han, you're very quiet. Are you doing good there? Sun Su, Cap, shallower. Okay, Tugasri, what do you say? Yen Li, Yvonne. So first, you can say in the ocean, so we begin. Okay, the water start propagating from the deep sea. So in the ocean, the wavefront are straight and parallel as the wave speed is uniform. So if you draw, this is how the seabed is look like. Okay, so this is what happened in the ocean. Ocean ini the depth is more uniform. Okay, the depth is more uniform. So the wave travel in a uniform speed. Okay, where the waves are straight and parallel. Okay, and then entering a shallow region. Okay, then what happens, students? Okay, so can you continue with the second point? So second point, when a wave moves towards the shore or approaching the shore, the depth of the seawater decreases. So you must mention the depth decreases. Okay, in the second point, depth decreases and so do the speed of wave decreases. Okay, okay. Then next, refraction occur and the seawater refracted towards the normal. See, from deep to shallow, refract towards normal, and by then follow the shape of the shore. Okay, at the cape, it will converge, follow the shape of a converge, and at the bay, it will diverge. So follow the shape of the bay. Okay, you boleh tambah di bawah sana. At the cape is the wave focus on one point, and then at the bay, it is diverged out. So from there, it follow the shape of the bay and cape in the same time. Okay, boleh Okay, then next. Okay, kita ada a few minutes left. Now it's 11 past 22. So I hope we can finish with the, I think this is the final question. Okay, for number 1. And now you can see a boy is beating a drum. Ini SPM, I forgot which year. I think it's 2016 if I'm not mistaken. Each beating a drum produces sound which can be heard by a man. Okay, so this is the man standing next to the drum, hitting by this boy. So the first one, what type of wave is sound wave, student? Now they're asking you for water wave. Before they ask you for water wave, now the question asking for sound wave. So what type of wave is sound wave? Sound wave. Stationary wave does not propagate, Nicholas. Stationary wave does not propagate with time. Sound wave is a what type of wave? How many type of wave we have, student? We have
2 types of
kita ada 2. Okay, so sound wave is transverse or longitudinal?
longitudinal.
This is longitudinal wave. Okay, you can say it is a longitudinal wave, or you can also say it is a mechanical wave, or you can say it is a progressive wave. Okay. Dia bukan stationary wave don't get confused. Okay, because stationary wave does not propagate with time. Dia tanya sound wave, not the wave produced on the diaphragm. Kalau dia tanya what is the wave produced on the surface of the diaphragm, itu stationary wave. Okay, but the sound wave coming from the diaphragm is a longitudinal wave. Alright, and now explain how sound is produced by the ear, by the drum, and can be heard by human's ear. If I'm not mistaken, you asked me this last time this question, how we are able to hear sound. So you have to explain here. How the sound produced by the drum and can be heard by human's ear. So how sound travel to our ears, students, 4 marks. So where to begin the answer from? So you can tell the moment the boy hit the drum, what happened? The moment the boy hit the drum. Okay, any idea? Air particles, what happened to the air particles? Sinway. Vibrating. Okay, so when the drum vibrates, so this is your first point. Drum vibrates, air molecule or air particle vibrates. Okay, vibrate how? Parallel to the direction of propagation of the wave. Okay, so the drum vibrates, air molecule or air particle vibrates in a direction parallel to the direction of propagation of the wave. Second, okay, from the vibration, it creates what? It creates compression and rarefaction. Remember, since sound wave is a longitudinal wave, so it produces compression and rarefaction region, okay, alternatingly, berturut-turut, berselang-seling. Okay, then what happened? Energy is transferred. Remember, energy is transferred when wave is propagating, it transfers energy. And finally, where is this energy reached? It reached our eardrum and then it vibrates our eardrum. So this is how we enable to hear the sound coming from the drum. So can you see the sequence? Boleh nampak tak turutan dia? It's starting from the vibration of the drum, which vibrate the air particles around it. Okay, and it travels parallel to the direction of propagation, producing compression and rarefaction region. By then, energy is transferred and it hit our eardrum and vibrates it. Alright? Okay, and then our brain tells us what sound we are hear. Apa suara yang kita dengar. Okay, then B. Okay, here you can see diagram B, sound wave produced by a distant train at night. Okay, so this is the train, you are standing at the side. Okay, Down here is the cold region, above is the warm region at night, and given the angle. Okay, ini in the cold region, ini angle in the warm region. Okay, this line show direction of propagation of the wave, where this man able to hear the sound coming from the train, obviously. Okay. So what is the question? Based on diagram, compare the wavelength of sound between cold region and warm region. So how to compare the wavelength in cold region and warm region? Look at the wavelength. Cool region is down here. See the wavelength? And warm region is up there. See the wavelength? So which one shorter, which one longer? Okay, which one shorter, which one longer? You can see in the warm region, the distance is greater from one and another. Compared to the warm region, the wavelength is shorter, right? So we say wavelength of sound in warm region is greater than cold region. See, must come with the parameter. Wavelength of sound in a warm region greater than that in the cold region. And then compare the angle between cold region and warm region. So you can see from the angle given here. So this is the angle in the cold region, and this is the angle in the warm region. So obviously, in the warm region, the angle is greater, 60 compared to 55 in the cold region. So we say angle in warm region is greater than cold region. Angle in warm region greater than that in cold region. Okay. And then what's next? Relate the wavelength with the speed of sound between the cold region and warm region. Students, how to relate wavelength and speed? What can you say? How to relate wavelength and speed between the cold and warm region? Sound travel faster in warm A or cold A?
Warm air.
Nanti you baca semula nota. So from the diagram we can see that wavelength increases, speed of sound increases. Okay, wavelength increases, speed of sound increases. Okay, then state the relevant physics concept. So what concept, okay, involved here? Propagation of sound in a warm region and cold region. So what is the concept?
Refraction.
Yeah, it is refraction of sound. Or you say refraction is enough. Okay. So this is how we tackle this essay question. Ini yang terakhir lah. Okay, terakhir ini kena leave it as your homework. Boleh tak? We try fikir answer.
Okay, okay.
Okay, they give you W, X, Y, and Z with this characteristic for you to choose. Which one is the best retaining wall to build a new harbor? Okay, it shows location and characteristic of 4 retaining wall. You have to justify the location. Either we have to build it at the bay or at the cape. Which one is a suitable place to build? And then the structure. Must the wall has a sloping retaining wall or a vertical retaining wall? How about the surface of the wall? Uneven or smooth is a better choice. And how about the height? Should be high or should be low? So you can think about this question first. Tomorrow I share with you the answer. Okay. So I guess that's all for today. Student, do you have anything to ask before we dismiss? If you have no further question, thank you very much for being here. I really appreciate the present, and you may prepare with the next lesson. Okay. So see you tomorrow. I leave you with this question. Try to think about them. Okay. So everyone, thank you. Have a nice day ahead. Okay. See you tomorrow. Siapa ada soalan boleh stay dekat sini . Tak ada soalan, you may leave now.
Teacher,
Thank you.
Yeah.
Bye.
cikgu boleh send